Ever get that feeling that your super smart AI assistant has a memory span that,
Right.
well, let's just say it could use a bit of an upgrade?
Oh, definitely. We're talking large language models, right? And that all-important context window.
Exactly.
Yeah.
How much stuff they can actually keep track of at one time,
Mhm.
it can be, frustrating. Like having this brilliant colleague who just forgets everything from 5 minutes ago.
Yeah. But what does it really mean for an AI to be truly on the ball, especially for something complex like, say, coding?
That's the key question.
Well, what's fascinating, I think, is this kind of dance between the enormous amount of knowledge they were trained on initially
Right, all that data.
and their immediate ability to actually use it for the task right in front of them. They've seen mountains of text, but how well they perform now really depends on having the right pieces handy.
Oh,
Without that relevant context, injected right when it's needed, their potential is still massive, but it's kind of latent.
dormant.
Mm.
It's latent. Good word. So, today we're really diving into a potential solution for this exact bottleneck, the Model Context Protocol,
Yeah.
MCP.
MCP, yeah.
Think of it like giving our AI coding buddies a much more dynamic, targeted way to grab the info they need,
Mhm.
specifically within something like the Cursor IDE.
Right. It's not just about jamming more memory in, it's about smarter access, more orchestrated access.
Orchestrated, I like that.
MCP is fundamentally about giving the model these controlled pathways, a way to reach out to external resources, specialized tools. It sort of supercharges its abilities beyond just what you feed it in the prompt.
Okay.
It's about making the AI a more active, informed participant, especially in something like software development.
Okay, so for you listening, our deep dive today is really zeroed in on understanding this Model Context Protocol, MCP, and how it works in practice, especially in Cursor.
Yeah.
Our mission, if you will, is to give you a solid grasp of what MCP actually is, why it matters, what you gain from it, maybe some best practices, and really how it empowers you if you're a developer using Cursor.
Sounds good.
All right, let's unpack this. And to really get why MCP is so interesting,
Yeah.
we probably need to start with the basics, right? How these LLMs even handle information in the first place.
Absolutely. And the cornerstone really is that context window we mentioned.
Yep.
In like simple terms, it's just the maximum amount of text an LLM can look at and actively remember during one interaction.
Okay.
But here's the thing, it's not measured in words like you or I count. It's measured in these units called tokens.
Tokens. Okay, I've heard that term. What exactly are tokens? Break that down a bit.
Sure. Think of tokens as like the fundamental particles of language for these models.
Okay.
They might be single characters or maybe bits of words, prefixes, suffixes, or whole words, sometimes even short phrases. It's how the AI breaks language down into manageable chunks.
So it chops up the text.
Yeah, that chopping process is tokenization. And for English, a very rough rule of thumb, maybe 100 tokens gets you around 75 words. But it really depends.
It fluctuates.
Totally. And lots of modern models use something clever called subword tokenization, like BPE, byte pair encoding.
BPE.
Yeah, it's smart because it lets the model handle words it's never seen before by breaking them into smaller, known pieces. Makes it way better with new or weird vocabulary.
Ah, okay. So this context window, full of tokens, is the LLM's immediate workspace for a task. And you said these windows have gotten much bigger.
Oh, yeah, hugely. We've gone from models with maybe a few thousand tokens to, well, now some cutting edge ones are pushing past 1 million tokens. It's incredible progress.
1 million. Wow. And what does that bigger window actually do for performance?
It has some really significant effects. A bigger window means the model can keep track of things over much longer texts or conversations, maintain coherence.
Right. It doesn't forget the beginning of the story.
Exactly. And it directly helps accuracy and relevance because it can juggle more facts, more pieces of information at the same time when it's figuring out what to say next.
Makes sense.
It can also mean fewer of those weird hallucinations times when the model just makes stuff up, because it has more real information right there in its immediate view.
Got it. More grounding.
And maybe most importantly, it lets LLMs tackle much more complex tasks, stuff that just needs a lot of input to understand. Think summarizing a whole chapter versus one paragraph. A bigger window makes the chapter possible.
Okay, that makes perfect sense. The more it can hold in its head at once, the better it can connect the dots. And yeah, avoid just winging it. But how does it process those tokens? It's not just storing them, right? What's happening under the hood?
Right, it's definitely not just storage. It's a pretty fascinating sequence. First, like we said, tokenization. chop it up.
Yeah.
Then each token gets turned into this dense list of numbers, a vector. It's called an embedding.
And embedding. Heard that too.
And these embeddings are cool because they capture the meaning of the token. Words or bits of words with similar meanings end up having vectors that are mathematically close together in this like high-dimensional meaning space.
So it's turning words into rich numerical fingerprints representing meaning.
Wow. Pretty much, yeah. Then comes the attention mechanism, specifically self-attention. This is really the powerhouse in these transformer models.
Okay. Attention.
For every single token in the input, the model calculates how much attention it should pay to every other token in that window. It's figuring out which other parts are most relevant to understanding or generating this part.
Like it's highlighting the important bits internally.
Kind of, yeah. Imagine you're reading, and your brain subconsciously emphasizes the key words. That's a loose analogy for self-attention.
Okay, very cool.
And because attention itself doesn't know word order, there's another piece. Positional encoding. This just adds a little signal to each token's embedding, saying I'm the first word, I'm the second, and so on.
So it knows the sequence.
Exactly. And finally, there's this amazing thing called in-context learning.
In-context learning.
Yeah, the LLM can actually learn from the examples you give it right there in the prompt without needing to be retrained. You show it a couple of examples of a coding pattern, and boom, it often gets the rule and can apply it straight away.
Like showing it a couple of times, and it just gets it. Wild.
It really is.
But, okay, even with these massive context windows, you're saying there are still fundamental limits. Just stuffing more and more data into the prompt isn't always the best plan.
That's absolutely right. Bigger windows are great, but they come with their own baggage.
Ah, okay. Like what?
Well, a big one is computational cost. Processing all that context takes serious horsepower. It often scales up really fast, sometimes quadratically with the input length.
Meaning more cost, more waiting time.
Exactly. Higher compute bills and latency. Nobody wants to wait ages for the AI to think.
True.
And there's this funny thing researchers found called lost in the middle.
Lost in the middle.
Yeah, it seems LLMs aren't always great at using information buried deep inside a really long context. They tend to pay more attention to stuff at the very beginning or the very end.
Huh. Like trying to find one sentence in a massive document.
Kind of like that, yeah. Plus, just dumping tons of stuff in, some may be irrelevant, can actually confuse the model. Noise can degrade performance. And, there are even security thoughts, bigger window, bigger surface for potentially unwanted stuff.
So it's not just about a bigger box. It's about having the right stuff in the box and knowing where it is.
Right.
Which, okay, leads us nicely into these smarter ways to manage context. What are people doing to work around these limits?
Right, there are several really clever strategies. A common one is chunking.
Chunking, breaking it up.
Exactly. Take your big document, break it into smaller pieces that fit the window. The challenge, of course, is keeping the connections between the chunks.
Yeah, how do you maintain the thread?
Tricky. Then there's summarization. You can actually use an LLM to summarize earlier parts of a conversation or document to save space.
Using the AI to manage the AI's memory.
Kind of, yeah. There's also a sliding window approach, processing text in overlapping segments for better continuity. And prompt engineering itself is huge.
How so?
Well, things like cleverly summarizing context within the prompt, breaking tasks into smaller prompts, putting key info in the right place, even using the model's awareness of position.
Okay.
And then, really crucially, there's the idea of using external memory, like knowledge bases or databases, storing info outside the main context and pulling it in only when needed.
Right. External memory sounds key for accessing huge amounts of data. And that brings us to retrieval augmented generation, ARA. Seems like everyone's talking about RAG.
Yes, RAG is definitely a hot topic, and for good reason.
So give us the deep dive on RAG. What is it? Why is it such a big deal?
Okay, so retrieval augmented generation, it's a really powerful approach that basically combines information retrieval like search with the text generation power of LLMs.
Search plus generation.
Pretty much. The core idea is, before the LLM even starts rating its response, you proactively fetch relevant information from some external knowledge source.
Like a company wiki or something.
Exactly. Or a database of research papers, product docs, whatever. You find the bits relevant to the user's query, and then you add that retrieved info directly into the prompt you send to the LLM.
Ah, so you're giving it extra targeted knowledge for this specific question.
Precisely. It gives the LLM access to stuff way beyond its original training data or what fits in the immediate window, especially current information.
Okay, so how does that actually work? The retrieval and adding part.
Typically, it's a few steps. First, you prepare your external data. chop it into meaningful chunks, maybe paragraphs or sections.
Right.
Then for each chunk, you create one of those vector embeddings we talked about, the numerical meaning fingerprint.
Okay, embeddings again.
Yep. You store all these embeddings in a special kind of database, a vector database, which is super fast at finding similar vectors. Now, when a user asks a question, you turn that question into an embedding too. Then you search the vector database. Find me the stored chunks whose embeddings are closest to this question embedding.
So finding the most similar meaning.
Exactly. Those top matching chunks are retrieved, added to the original prompt, and then the whole thing goes to the LLM to generate the final answer, now armed with that extra context.
That sounds incredibly powerful. What are the main advantages of doing it this way?
The benefits are pretty huge. First, access to current or proprietary data that LLM wasn't trained on, that's massive.
Yeah, keeping it up to date.
Right. And because the answers are grounded in these retrieved documents, it usually means better factual accuracy, fewer hallucinations.
Makes sense. Less guessing.
You also get domain specialization without having to retrain the whole giant model, which is super expensive and slow. For companies with lots of internal knowledge, RG is often way more practical than fine-tuning.
More agile.
Definitely. And another big plus, traceability. You can often point right back to the source documents that informed the answer. Builds trust, allows verification.
Okay, so RA is about getting the LLM the right info just in time, even if it's external. You mentioned it complements large context windows. How do they fit together?
Yeah, they work well together. Think of it like this. A large context window is like having a huge bookshelf in your head.
Okay.
RA is like having a super efficient librarian who, when you ask a question, instantly finds the exact right book and page from a much bigger library elsewhere and hands it to you to put on your immediate bookshelf.
Ah, nice analogy.
RA shines when you need really up-to-the-minute info or very specialized knowledge that's too niche to include always, or when you need those citations. The large window still helps process the retrieved info plus the original query effectively, but RA ensures the most relevant external knowledge gets into that window.
That clarifies it perfectly. So RA is a major strategy. Are there other techniques people use to optimize context use, maybe save on costs?
Oh yeah, lots of other clever tricks. There's context caching.
Caching.
Yeah, if you often use the same big chunk of context, like system instructions, you can pre-process and store it so you don't send it every single time. Saves tokens.
Sure.
There's also context filtering or distillation. Sometimes you use a smaller, cheaper LLM to first look at the ARGI results and pull out only the absolute essentials before sending it to the big, powerful LLM.
Pre-filter step.
Kinda, yeah. Then just basic prompt optimization, being clear, concise, specific, don't waste tokens.
Good hygiene.
Model selection or routing is another one. Use a cheaper model for simple tasks. Save the expensive powerhouse for the hard stuff.
Right, tool for the job.
Even fine-tuning a model on a specific domain can sometimes mean you need less context in your prompts for that domain. And just asking the LLM for structured or concise output can save tokens too.
So lots of ways to be smarter.
Definitely. The whole game is shifting from just more context to the right context efficiently.
Okay, that's a perfect setup. It really highlights that it's about quality and intelligent delivery, not just quantity. Which brings us finally to the main topic, the Model Context Protocol, MCP. We've talked context limits, we've talked strategies like R. Where does MCP fit in all this?
Right. So the Model Context Protocol, you can think of it as an open, standardized way for applications like an IDE to talk to external systems that can provide either extra context or specific tools for an LLM.
A standard way to connect LLMs to outside stuff, like a plugin system.
Exactly, like a universal plugin system designed for LLMs. The goal is to abstract away all the custom one-off integration work. Instead of every app having to build unique connectors for every database, every API, every tool it wants the LLM to use, MCP provides a common language, a common set of rules for those interactions.
So it's like a universal translator or a standard plugin socket system, allowing different apps and external services to talk LLM friendly.
That's a great way to put it, a standard interface. Can you tell us a bit more about the architecture? What are the main parts?
Sure. High level, you've got three main players. First, the application itself, the client, like Cursor IDE. It manages the whole process.
Okay, the app.
Then you've got the LLM, obviously, which might realize, hey, I need to do something external.
Right.
And third, you have the MCP server. This is some external process or service that actually implements the MCP standard and exposes specific tools or resources that the app can offer to the LLM.
The app, the LLM, and the MCP server doing the external work.
Got it. And how do they interact? What's the flow when the LLM needs something from an MCP server?
Typically, the app first discovers what MCP servers are available. Then, when the LLM figures out it needs an external capability.
Like querying a database.
Exactly. The application, often with user permission, importantly sends a request, formatted according to the MCP rules, to the right MCP server.
Okay.
The MCP server gets the request, does its thing, runs the query, calls the API, executes a script, whatever, and sends the result back to the application. And the app gives that result back to the LLM. Precisely. The application takes that result and incorporates it into the context it feeds back to the LLM to continue its job.
Makes sense.
Huh.
The app is the middleman, using the standard MCP language.
Yeah.
Now, I heard MCP supports different ways for the app and server to talk. Transport mechanisms.
Yeah, mainly two key ones right now, Stadio and SSE.
Stadio, like standard input-output.
Exactly. Stadio is for running MCP servers as local processes right there on your machine. The application, like Cursor, usually handles starting and stopping these processes automatically.
Okay.
Communication just happens via the standard input and output streams of that process. Simple. It's good for tools that are just for you, running locally, not shared. Configuration is usually just telling the app the shell command to launch the server.
Okay, Stadio for local tools on my machine. What about SSE?
SSE stands for Server Sent Events. This one lets MCP servers run either locally or remotely.
Over the network.
Yep. Unlike CDO, you usually manage SSE servers yourself, start them, keep them running. Communication uses standard HTTP and this server-sent events protocol, which is good for servers pushing updates to the client.
Okay.
SSE is ideal for tools you want to share with a team or access remotely, or maybe connect to a third-party API service that has an MCP interface. Configuration here involves giving the application the URL of the server's endpoint.
So Stadio for local managed processes, SAE for independent, potentially remote or shared services using HTTP. Makes sense. Now, you mentioned servers expose tools and resources. What's the difference?
Good question. So tools in MCP are about specific discrete actions the LLM can ask the server to perform.
Like run this query or call this API.
Exactly. Concrete actions. Query a database, call an API, run a script, fetch a web page. The LLM says, I need to use tool X. The app sends the request with any needed arguments. The server does it, sends back the result.
Okay.
And right now, in Cursor's implementation, tools are really the main focus. That's what's actively used.
Gotcha. And resources, what are they meant to be?
Resources, based on the spec, seem intended for more like static or structured data sources the LLM could access.
Like fetching data records or maybe a database schema.
Yeah, something like that. Getting info from a knowledge base, schema details, predefined data sets. But it's important to note, this resource part isn't really implemented or supported yet in Cursor's MCP setup.
Okay. So it's mostly about actionable tools for now.
For now, yes. That might evolve, but tools are the main capability today.
Interesting. So how does an app like Cursor actually find and connect to these servers? Is there a setup file or something?
Yep, usually configuration. In Cursor, you'd typically edit a specific config file, probably JSON.
Okay.
In that file, you tell Cursor about the servers. For CDO, you give it the shell command to run. For SSE, you give it the server's URL.
So the user explicitly registers the servers they want to use.
Exactly. It gives you control. And the beauty of MCP is Cursor only needs to implement the MCP client part once. Then it can talk to any server that follows the MCP rules, whether it's Stadio or SSE.
Right. Standardizes the connection. Fosters a whole ecosystem.
That's the idea. Makes integration much simpler and opens the door for lots more tools and context providers down the line.
It definitely sounds like MCP could be a real game changer, making LLM apps way more versatile, plugged into the tools developers actually use. So, let's get concrete. How is this working right now in Cursor IDE?
Okay, yeah. Cursor is built AI first, right? And MCP is a key way. It extends its AI smarts beyond just the code in your project.
Right.
While Cursor already has some really solid native ways to get context.
Let's touch on those first, maybe, just to set the stage. What does Cursor do natively for context?
Sure. Well, a big one is its code-base indexing. It scans your whole project, understands the structure.
Okay.
So when you use @codebase or Sutral plus enter, it uses RG-like techniques internally to find relevant code snippets from your project to feed the AI. Though some people find it struggles a bit with really massive files, sometimes just giving outlines.
Good to know. What else?
Well, obviously, the current file you're editing and where your cursor is, that's always implicit context for chat or commands.
Makes sense. Local context.
Then you have the @ symbols, super flexible, at files to point to specific files, at folders for whole directories, at code for selecting snippets.
I've seen those.
At docs is cool too, brings in docs for libraries. Or you can add your own via local paths or URLs. Cursor re-indexes these periodically.
Nice.
There's also at Git for history or diffs, at web for web search results, at definitions for looking up code symbols, at lint errors to tell the AI about problems.
Wow, lots of options.
Yeah, at recent changes, at cursor rules to reference those persistent instructions, at notepads, even pasting web links with @works. It's quite comprehensive.
And those rules files you mentioned, how do they fit in?
Right. .cursor rules files are either per project or global. They let you set persistent instructions.
Like coding standards.
Exactly. Or project background, key terms, stuff the AI should always know for this project. It gets prepended to every prompt. The .cursor rules format is the newer, preferred way.
Okay. And then there's the agent mode, which tries to handle bigger tasks, figure out context itself, even run terminal commands, but usually asks for your OK first, unless you use YOLO mode. YOLO mode. Okay, so Cursor has a strong built-in context game. How does MCP plug into this? How does it let Cursor talk to external stuff?
MCP basically bolts onto all of that. You configure it in that settings file we talked about.
Right. Tell Cursor about your servers.
Yeah. Provide the shell command for SADIO servers, the URL for SSE servers. Once they're registered, the tools those servers offer become available to Cursor's AI agent.
The agent can then choose to use them.
Potentially, yeah. When it thinks a tool could help with your request, it can propose using it. And crucially, by default, you have to approve it before the tool actually runs. Security first.
Okay, that's important. So could you give us some real-world examples? What kind of things could I actually do with MCP in Cursor?
Okay, imagine you have a local database for your project. You could write a simple MCP server that knows how to query it. Then in Cursor, you could ask the AI, show me users who signed up last week. The agent might say, okay, I can use the query database tool for that. You approve. It runs the query via your MCP server, gets the results back, shows them to you, all inside Cursor.
Wow. No switching apps, no writing SQL myself necessarily?
Exactly. Or think about Notion integration. An MCP server could talk to the Notion API.
All right.
You could give Cursor a link to a requirements page in Notion, ask the AI, summarize the main user stories. The agent uses the Notion tool via MCP, fetches the page content, summarizes it. Boom.
That's slick. Cuts down on so much context switching. What else?
GitHub operations. An MCP server could interact with the GitHub API. Maybe the agent could create a new branch for you, draft a pull request description based on your changes, even search code across the repo.
PR generation, branch creation. Nice.
Or maybe your team has a shared knowledge base. You could build an MCP server to query it, maybe even a vector database for semantic search, giving the AI persistent memory across sessions.
Persistent memory via MCP. Interesting.
Could even integrate with things like Stripe. Check this customer subscription status if someone builds the MCP server for it.
Okay.
And maybe the biggest potential is connecting to custom internal tools, your company's build system, internal linters, proprietary knowledge bases, or RAG over your private company docs, like that GroundX example people talk about.
So basically linking Cursor's AI to potentially any tool or data source you use, as long as there's an MCP server for it.
That's the promise, yeah.
It really sounds like it could change workflows. Less bouncing around, more automation, a way smarter AI assistant right in the editor. Are there any catches? Any current limitations with MCP and Cursor?
Yeah, a few things to be aware of. Right now, Cursor seems to only pass the first, 40 discovered MCP tools to the LLM agent.
Okay, a limit on the number of tools.
Could be an issue if you have tons of servers or tools. Also, using Cursor in remote development setups like over SSH can be tricky with MCP, especially sterio servers that need to run locally. That's likely to improve, though.
Remote development needs work. Got it.
And like we said, the resources part of the spec isn't really there yet in Cursor. It's focused on actionable tools.
Okay, so room to grow, but still sounds incredibly useful. It's like this synergy, right? Cursor knows the code, MCP lets it reach out to everything else.
Exactly. A layered approach to AI assistance.
Now, what if someone listening is thinking, hey, I want to build one of these, maybe connect their own custom tool. What are the best practices for developing an MCP server?
Good question. If you're building one, first off, language flexibility is key. MCP uses Stadio or SSE, so pretty much any language that can handle basic I/O or HTTP can work.
Okay.
Performance is super important, especially for local Stadio servers. Slow tools make for a laggy cursor experience.
Right, keep it snappy.
Robust error handling is critical. Your server needs to handle failures gracefully and tell cursor why it failed in a structured way.
Don't just crash.
Please don't.
Yeah.
If your tool needs to remember things between calls, state management is the server's job. And clear definitions for tool inputs and outputs are vital, so the LLM knows how to call it correctly.
Makes sense. Define the interface clearly.
Yeah.
What about security and reliability? We're talking about letting AI trigger external actions.
Hugely important. Cursor's default ask for approval is the main safety net. That YOLO mode for auto-running tools. Use it very carefully, only with tools you absolutely trust.
Yeah,
On the server side, build for reliability, handle edge cases. If you send back images, use the right format like base64, the whole system's only as reliable as the servers themselves.
quality in, quality out applies to the servers too. So any general tips for making good, effective MCP integrations in Cursor?
Yeah, definitely. Try to make your tools clear and focused. One tool, one job, usually better than one giant complex tool. Aim for granular atomic actions the LLM can chain together.
Keep it simple.
Optimize for performance, always. If you're building shared SSE servers, think about scalability. Be aware of any downstream costs if your tool calls a paid API,
Good point.
Document your server and its tools well. And security hardening is non-negotiable. Validate inputs, sanitize outputs, especially if you handle sensitive data or perform critical actions.
Solid advice.
Remember, MCP is just the plumbing. The real value comes from the quality and usefulness of the tools and data you connect through that plumbing.
That's a fantastic way to put it. The plumbing versus what flows through it. So wrapping things up, MCP is really this standardized bridge, right? Connecting LLMs to the outside world. And we see it working right now in Cursor.
Exactly. It's a move beyond just bigger context windows towards smarter, more dynamic, more extensible AI assistants. That mix of Cursor's native context awareness and MCP's ability to reach out is really powerful for developers.
It really feels like the future of AI in coding tools.
It's definitely a very promising direction.
So for you listening, here's something to chew on. Think about the specific tools, the APIs, the data sources you use every single day in your own development work. What if you could build a custom MCP server to wire those directly into Cursor? Let the AI interact with them intelligently, automate tasks, fetch info, get way better context.
What could that actually unlock for you?
It really opens up possibilities.
We definitely encourage you to check out the Cursor docs on MCP. Start thinking about how you might leverage this. It could really change how you work. Thanks for taking this deep dive with us today.